Greetings, students. I just wanted to present another video. This video is a combination of D over H, IV, and the pediatric dosage calculation. So we'll start with our D over H formulas. So number one, we have the doctor's order, 125 milligrams by mouth. What you have available is oral solution, 250 milligrams per 5 milliliters. This one is pretty simplistic for D over H. The setup is 125 divided by 250 times 5. And the answer comes out to 2.5 milliliters is the answer. Very simple, right? Number two is another D over H. The order is for 0.05 milligrams PO. And then what we have available are tablets labeled 25 micrograms. So you know you're going to have to convert milligrams to micrograms to fit what you have in your stock. So you're going from largest to smallest. So you're going to multiply by 1,000. And what do we come up with? 50. So it's 50 micrograms divided by what you have available, which is 25. And what do we get? 2 tabs, right? 2 tabs is the answer. Sorry if there's a glare. Maybe if I turn this light off, it'll get rid of some of the glare, but maybe not. All right, so moving on to number 3, we have 0.4 milligrams by mouth. What you have available is tablets, 200 micrograms. So you're going to convert what you have, what the doctor ordered, to what you have in supply. Milligrams to micrograms, largest to smallest. You're going to multiply by 1,000, and your answer is going to be, answer is 400 divided by what you have available is 200. And of course, you know it's 2 tabs is the answer for these. So I hope that you could see these clearly. All right, so we're going to pause for a second and then get the next few problems to you, if I can find my cursor. Right. All right, folks, here are a few of your IV calculations. The formulas are listed here as a reminder. We have the first formula, milliliters infused divided by hours, which gives us milliliters per hour. And we have the other formula, milliliters infused divided by minutes times the drop factor, which gives us our drops per minute. All right, so the first one is 1,800 milliliters divided by 24 hours. All right, so what do we do with that one? All right, so this formula, there's no conversion needed because according to this formula, it's already in hours, right? So we have our 1,800 milliliters divided by 24 hours, right? This one is pretty simplistic, and the answer comes out to 75 milliliters per hour. Let's double check the math on that one. Divided by 24, it does give us 75 milliliters per hour. All right, so here's the next one. We have 100 milliliters of quarter saline in 45 minutes by infusion pump. So there's no drop factor here, so you know we're using this formula. So you're going to have to convert these minutes to hours to fit the conversion. So to convert hours to minutes, what do? We divide by 60, right? Divided by 60, and it comes out to 0.75. So we have 100 milliliters divided by 0.75. The answer comes out to 133.33333, but we always round to the nearest whole number with IVs, so it's 133 milliliters per hour for this one. All right, so we're going to add a few more IVs. All right, folks, here's our second or third set of problems. So the first we have, I put the formulas at the bottom as a reminder. Milliliters infused divided by hours gives us milliliters per hour. Milliliters infused divided by minutes times the drop factor gives us drops per minute. So number one is 1,000 milliliters of D5W in 10 hours. The drop factor is 10. So the setup for this one is very simple. You have to convert the hours to minutes to fit the formula. So with this one, you are going to multiply by 60, and the setup will be now 1,000 divided by, sorry for the small space, divided by 600 times the drop factor, which is 10, and the answer comes out to 16.6 something. So the answer, round to the nearest whole number, is going to be 17 GTT per minute for the first one. All right, so we move on to the second one. The second one is 1,500 of Ringer's lactate in 12 hours. The drop factor is 15. Same thing, you have to convert these hours to minutes to fit the formula because there's a drop factor. You multiply this by 60 and it comes up to 720. So let's squeeze this one somewhere. So it's 1,500 divided by 720 times the drop factor, which is, sorry, this is terrible. Let's do a little bit better with this one. So it's 1,500 divided by 720 times the drop factor, 15, can squeeze it better. So 1,500 divided by 20, divided by 720 times the drop factor, 15. Oh my God, what am I doing? Yes, by 15, the answer comes out to 31.25. We round to the nearest whole number, and it's going to be 31 GTT per minute for number two. Sorry, the board is small. All right, and moving on now to number three. We have 40 milliliters in 20 minutes. The drop factor is 10. So this one is in minutes, which there's no conversion necessary, right? So it's just 40 divided by 20 minutes times the drop factor 10. Very simple. And the answer comes out to be 20 GTT per minute. Yes? All right. And the last one is 800 milliliters in Ringer's lactate in 12 hours. And the drop factor is 10. We have to convert these hours to minutes to fit the formula. We multiply it by 60, and it comes out again 720. So that would be 800 divided by 720 times the drop factor 10, and the answer comes out to 1111 something, but it's 11 GTT per minute is the answer for that. Yep, that's it for that one, folks. And we're going to move on now to the, let's try a few pediatric ones. See how we do on those. All right, folks, here's our first pediatric dosage. All right, it says the child's weight is 11.2 kilograms and has an order for acyclovir 120 milligrams IV every 8 hours. The safe dosage range of acyclovir is 25 to 50 milligrams per kilograms per day. What is the safe dosage range for 24 hours? So you understand that first, We have to convert the child's weight to kilograms if it's in pounds. So it's already converted. So all we have to do is do the math. So we have 11.2 and we times it by the 25. We take the same 11.2 and we times it by the 50. And we come up with 280 milligrams per 24 hours. And we take the same 11.2 times 50, and that gives us 560 milligrams per 24 hours. So how do we determine if the dosage is safe? Actually, it didn't ask us that. It's just asked us what's the safe dosage range, right? And here it is. So let's say I ask you, is the dosage ordered safe, which is the 120 milligrams of acyclovir, and it's ordered every 8 hours. So let's go ahead and determine if the dosage is safe. So in order to do that, we take what the doctor ordered and we multiply it by the frequency. So we have our 120, which is what the doctor ordered. The frequency is every 8, which would be 3 times. So that would be 120 times 3. The answer comes out to 360. And then we want to know if the 120 milligrams is safe. Yes, because it falls within the safe dosage range. Okay? All right, moving on to the next one. Right, here's our next problem. The doctor orders amoxil for a child that weighs 63 pounds. The safe dosage range is 50 milligrams per kilograms per day every 8 hours. So we're asking, what is the safe dosage range and what is the single dose? Okay, so step 1, we have to convert these pounds to kilograms. We divide by 2.2, and that gives us 28.6 is the weight in kilograms. So we take our 28.6 and we multiply it by the 50. And we come out with 1430, 1430 milligrams, right? Per day or per 24 hours, right? Now is asking us what is the single dose, right? So in order to get the single dose, we see that the frequency is every 8 hours. So that means that we need to break this down a little bit further. So we take our 1430 and we divide it by 3. And then our single dose would be 476.6 something, but we round it to the nearest 10th, and it's 7 milligrams per dose, right? So it's 476.7 milligrams per dose is the answer for this one. All right. All right, folks, here's our next pediatric problem. So the doctor orders cefazolin 350 milligrams IV every 4 hours. The child's weight is 31 pounds. The safe dosage range is 25 to 75 milligrams per kilograms per day. And we're asking, is this dosage safe? So the way to determine that is that you have to work through all of the steps. So step 1 is to convert the child's weight to kilograms. So we take the 31, we divide it by 2.2, and we come out with 14.09. We round it to the nearest 10th, so it's 14.1 kilograms, right? So we take that 14.1 kilograms, we multiply it by the safe dosage range, the 25. We take that same 14.1 and we multiply it by the 75. And we come out with 352.5 milligrams per 24 hours or day. Then we take the same 14.1 times 75, and it gives us 1,000 057.5 milligrams per day or per 24 hours. All right. So it's asking us if this 350 milligrams is safe, right? So we take the 350, we multiply it by the frequency. So every 4 hours is administered 6 times in a 24-hour period. 6 times 4 is 24. So we take our 350, we multiply it by 6, and we come out with 2,100 milligrams per day, right? So this falls way beyond the recommended dosage range, right? So this is not safe, not safe. So no good for this order, right? All right, thank you.